On Zeta 26, the quantum network is gone. What remains is the relic ring, physical fiber, long-range laser hops, and tower relays. This console routes a packet across the network using the actual propagation rules from the project. In this run, we want to show 4 things. The universe boots from config, the packet survives multi-hop codex translation, the latency can be explained from the equations, and the route adapts when parts of the network fail.
Starting on, by clicking a planet, you can inspect their description in the node inspector. The codex base, the radius, the atmosphere, the refraction index, and how many towers it has. Also, there is this grid view where you can map out the absolute positions, the XY coordinates of the planets. And also there is the zoom in, zoom out features, and also the UI component height toggle, so you can view the system as you wish.
Now, I set Aegis as the origin and KLM as the destination. The important thing is that the router does not go direct. A straight Aegis to KLM laser hop is about 6 to 8 million kilometers, which is beyond the 50 million kilometer limit, so that hop is not legal. The engine bridges through dawn instead. That's LMAX doing real work. The route is shaped by the physics constraint and not by presentation. This is where the latency figures come from. For the Aegis to dawn leg, the backend first computes the straight line gap between the planet centers, scales it to kilometers, and subtracts the radius and atmosphere terms. Now I'll send the word hello. At each hop, the payload is re-encoded into the local codex. Aegis in base 8, dawn in base 6, then KLM in base 14. Even though the representation changes at each stage, the delivered message is still the original one. The full log exposes that step by step: tower entry and exit, ring arc, codex conversion, and void hop distance and latency. And if the panels get in the way, each HUD card can collapse down to its header, so the 3D route is still easy to inspect. Now for the failure test. I'll take dawn offline in the middle of the mission. The network marks the node as dead, removes its links, and immediately recomputes the route. This time the path goes through Elysium. If I send again, the packet is still delivered, but now the codex chain changes and the latency is recalculated for the new geometry. That's dynamic routing under failure, not just a cosmetic status change. I'll push it further and take Elysium down as well. Once both 2-hop bridges are gone, the only legal route to KLM is the longer path: Aegis to Boreas, Boreas to Phoenix, then Phoenix to KLM. We are up to 3 hops now, and that extra distance shows up directly in the latency. The engine still finds the best remaining legal route, and the packet still gets through. This is the hard failure case. If I kill Phoenix, KLM loses its last legal neighbor. At that point, every live route within the laser range is gone and KLM is isolated. The router does not invent a path or leave the stale data in place. It reports the correct state as undeliverable. That's just as important as finding a valid route when one exists. One reset brings the whole ring back online and restores the original route. So, with one press, we've shown config-driven initialization, codex translation across multiple hops, latency derived from the published equations, and rerouting under cascading failure. That's the full behavior of our Relic Ring Router.